Hello everyone, welcome to another event organized by JUG Istanbul. Today we have Bazlur Rahman with us. He will be presenting on the topic of virtual threads. Before we begin, I would like to introduce our community. User Group Istanbul is one of the most active Java communities in Turkey. By organizing webinars, meetups, hackathons, bootcamps, and participating in the Global Day of Code Thread, we contribute to the Java community. We host annual international event, Java Day Istanbul, every year. We invite speakers we consider to be high quality from various parts of the world. We have more than 7,500 members and have conducted over 110 events of this kind. We are an open non-profit organization, and to stay up to date with the latest developments in Java, we have a podcast series that we release once a month. You can access them on Spotify and iTunes. Every month we host JetBrains giveaways. If you would like to participate, you can follow us on Twitter. If you are interested in joining the Java User Group Istanbul or getting more information, we welcome you to our Slack channel. To reach out to us and follow us, you can use our email address, hello@jugistanbul.org, handle @JUG_Istanbul, and other social media links available in the QR code. Thank you for listening to me. Now I will pass the platform to my friend Ömer Naci. Enjoy the presentation. Ömer Naci.
Hello everyone again. We have a interesting event next month, and it will be related Apache Camel in beginning of September. Otavio from Apache Camel team will talk about the new features of Camel, and we will share the event details next week. And we are also waiting for your participation in this event. And another program is Atom Open Source Project Contribution Program in Java User Group Istanbul, and we aim to support open source projects. And our first period has come to end previous month. You can see our statistic for the first period are as follows. And now we started mentor applications for the second period. You can see calendar or roadmap on our website. And the documentations also on our website. I gained new skills as a consultant in the first period. I will also be mentor probably in the second period. And Nesrin, another consultant, and she achieved good results, and she will also take part among us as a mentor next period. And today we will upload this event recording to YouTube, our YouTube channel. So that's all. Bazlur, the platform is yours. You can start your presentation.
Thank you everyone for joining, and I definitely thanks a lot JUG Istanbul to host me. So let me start my presentation. Just give me a second. I'll start my screen. All right. Hopefully you can see my screen by now.
Yes, it is clear now.
Okay, perfect. So, all right. So today we're gonna talk about a virtual thread, and this is probably one of the biggest feature in Java since many years. I would say since Java 8, and Java 8 pretty much reshaped our understanding and how we could and how we, write our softwares using Java. and this is going to be the big thing that's going to change our understanding on concurrency. So that's the idea. Basically, I would try to explain what it is and how it is developed, and I'll show you some demo. And meanwhile, if you have questions, feel free to ask it. There is no perfect time to ask questions. You can ask anytime, and I'll try my best to accommodate as much as I can. I can promise that I'll be able to answer all of your questions, but obviously I'll try my best. So that's the title: Virtual Thread Ushering in a New Era of Concurrency. And yeah, let's go ahead. So my presentation would be in two parts. I'll giving you a bit of background so that we understand where we were, and then I'll show you where we are heading. So that will help you to understand and relate what problem we had and then what problem we are basically solving. So yeah, so that's the agenda pretty much, and I'll start from here basically. So the idea is, so let me see if I can. Okay, looks like this time it's working. So the idea is pretty much we all know about it, right? Java is made of threads. This line is not exaggeration. I mean, from very early age when Java introduced thread, it was one of the reasons why Java is so popular and it picked up, right? That time in 1995, no other language would able to support concurrency that way Java used to do. Now everyone does. Anyway, so now question gets to be, what is essentially a thread is. So if I simplify in a language, I mean human language, I would say threads are just unit of execution in Java. Basically, you have a few lines of code that you want to execute, and in Java, threads basically does that. A thread does that. So if you have more threads, that's essentially means you have more execution environment. So if you have more execution environment, that also means we can do more things simultaneously, which is interesting, right? I mean, think about the scenario in your applications. You want to do a thing, and it's it's doing something in background or foreground, doesn't matter, but it's taking some times. While it's doing things, you are not able to do anything else. That's frustrating. You are just staring at your screen, and waiting to finish that particular task, and then you can start the next one. That's pretty frustrating. But if you can do simultaneously a lot of things, one thing is being executed, and at the same time, you can pretty much feel free to do another things simultaneously. That's definitely amazing, and that gives us the responsiveness we want, and freedom to do a lot of other things at the same time. So one thing I do have to clear first, that there's a distinction between concurrency and parallelism. I am going to talk about concurrency the whole time. Parallelism is definitely another aspect. With that, we can speed things up, but there is a distinction between that. Concurrency is about doing multiple things simultaneously, and parallelism is, on the other hand, I have a big task. I want to divide them and distribute them into multiple core. Let's say I have a computer which has 8 core. If I only use 1 core and 9 are idle, rest of them are idle. That's not, doesn't make sense, right? So what I would do, I have a let's say I have a huge calculation. If I can distribute this work into multiple core, I can do things faster, right? Because all of them are working parallelly. So that's the parallelism. And concurrency is about executing a lot of things simultaneously. Some of them are independent, some of them are, probably not independent. They are dependent on each other. But as a whole, the idea is, let's say we're eating on a table 10 peoples, and all of them are making progress, all of them are eating. It's not about one is eating, and then once he's done eating, the other person will start eating. That's not what we want. So in general, concurrency is about making progress with everyone, right? Everyone making some progress, so that we can see, and we can continue, and it becomes responsive. So we have to keep that in mind. So in this presentation, the whole time I'm going to talk about concurrency, not parallelism. So all right, moving on. So now that we know the distinction, and let's see what are the areas Java threads are threads are used in Java. I would say it's pretty much in all layers, even though if you don't use threads if you don't write concurrency code in your day-to-day Java programming, that's totally fine, but you are still using threads in one way or another. So let's say, here's an example. Let's say I have written a hello world program, right? Basically, it has a main method, and inside this curly brace, I have just one statement, which is printing the hello world. The idea is this particular code is also being executed by a thread, and that thread called main thread, and from where every other thread starts in our Java application. But look at that in this debugger screen in the bottom of this frame. You see there are other threads that are running. For example, final ledger, signal dispatcher, and common cleaner, and there are other threads basically. So when JPM starts, it starts with a lot of threads, and it's all in all layers: exceptions, debugger, profiler, name it. In every places you see threads are being used. Moving on. So now the very fundamental question: how do we create a threads? It's basic. From very fundamentally, we start creating threads like this. We create an instance of threads, and then we pass the runnable interface. There are multiple ways to create threads, but this is the simplest form of creating threads. And if you call thread.start, and this is the line that you added inside this two curly braces over here. Maybe I can show you that in a code that will make you clear, much clearer. So the idea is, if you there is a curly brace over here, and then it ends over here. So I have a main method over here, right? And then it starts from this curly brace, and then it starts from this curly brace. So the execution of basically, I want to execution this in these few lines, right? This is what this program is supposed to do. So when I start this application, from this curly brace, a main thread will start working, and main thread will see there's a code over here, and it says create a thread, instance of thread. So it creates an instance of thread, and inside this instance of thread, there is another curly brace. Basically, it's a lambda expression, but we can do a runnable interface, but totally fine. So this is basically another block of code. The main thread is not going to execute this block of code. It's a responsibility of this brand new thread that we're creating, and it will jump over here, and over here it will see that thread.start. Basically, we're starting a new thread. That's it. So when we start a new thread, if I don't use this line, what would happen is, so main thread will start, and then it will it will come over here, it will start the threads, and then it will exit over here while this thread is working. I can show you demo quickly. So basically that's what happens. So sometimes there are cases when it could happen that the application even start and exit without printing this, because before reaching, for example, if thread, let me make it a daemon thread, set daemon show, and now I'm going to start it again. Let's see what happens. So I'll put the sleep over here so that I can see something is being worked on. So let's start. You see, nothing got printed. The only reason is, main thread started from here, and then it created an instance of thread, and then it started, and it doesn't have anything else, so it exited. And when it exited, since it's a daemon thread, it's also died. So what I have to do is I have to wait until this particular thread finishes job. So that's basically this line stands for anyway. So this is how we essentially create threads. So moving on, and so basically this example how if we want to sleep a little bit, so that we can show demonstrate that it's doing some work. Now, so what I'm gonna do is let me go back to the IDE again. So let's remove that for now. And since I'm sleeping a long while, what I'm gonna do is I'm gonna take a thread dump. So let's see what it looks like. So okay, how do we do that? Sorry. So it's running, and there is a button over here called thread dump, right? So when you click on it, you'll see all the threads over here. So this is my thread. This is our thread that I have just created, and it's a thread 0. It's sleeping because I put it in sleep, so it's sleeping. And if you can see over here, there is a 2 ID over here. One is TID and another is NID. What it means, I'm gonna talk in a minute. So what happens is in Java thread, the thread that we are seeing, or we're iterating, or we're creating, manipulating, all sort of things, are not actually Java's construct. Basically, what it is when we create a thread in Java, it basically asks operating system to give a thread. What I'm trying to say with this TID is it's a operating system thread, or it's a native thread. Java doesn't handle threads by itself. So what it does is it's basically a thin wrapper around this operating system thread. So it's a 1-1 mapping. So we can say easily Java thread is basically operating systems thread, or native threads, whatever you can call it. So that's what it is essentially. And threads are expensive. Why so? So the reason is we can create only a limited amount of threads. Operating system doesn't allow to create unlimited amount of threads. There are various reasons why it's expensive. For example, the number of threads we can create definitely limited. Like there are other reasons. For example, it takes 2 MB of memory outside of heap. And when you are creating a lot of threads, you are also doing context switching, which takes time, right? So now think about a scenario. You are building a web application and you want to maximize your throughput. And traditionally, the kind of web application we build is a kind of model that user sends a request and it is served. So on each request, we basically this whole round trip from user to user. I mean, user comes to send a request to the server does some processing and then send back to the request to the user. This whole HTTP round trip is done by one particular thread. So basically, let's say I have 100 threads in my my application is using 100 threads. That means I will be able to concurrently, manage 100 request response, right, for a particular period of time, because so that's my throughput in high level. Now I want to increase that throughput. What can I do is we can increase the number of threads, and that's how we basically in Java we have been doing, improving our throughputs. So let's say my server is, modern operating system, in fact, can handle that. Let's say I want to create, 1 million concurrent connection with my server. Can it handle? Can my Java application, really serve 1 million requests at a point of time? Theoretically, it can, because socket can, modern socket can handle 1 million connection. But the question gets to be, if we want to, serve 1 million requests, we probably need 1 million threads to handle those, request response, right? But in theory, that would require like, 2 terabytes of memory outside of the heap, because each thread requires 2 megabytes. So basically, threads are heavyweight things. We cannot create unlimited one. So that's the idea. So over here, I have written a code that basically counts. You can copy this code and run on your machine. I certainly don't want to run that code over here now, because it will probably break my Zoom session, which definitely I don't want. But feel free to run this code on your own machine. So basically what happens is, if you run this code, you will see after a while an exception will occur, something like that. So it will say out of memory, unable to create native threads. So because you run out of memory. And I have tested with a machine which is 16 GB a operating system with 16 GB memory, and I was able to create around 4,000 threads basically. So that's the number basically. If you have more memory, you can go higher, but again, there are other costs is going to accumulate. So basically, what I'm trying to say is, threads are limited. You cannot do a lot. And that means you cannot create, can achieve the throughput that you want. We have some other ways to, solve this problem. I mean, we can go, we can do, what do we say, reactive programming, or we can have a lot of copy of the same program, all those techniques. But basically, essentially, we are limited by the number of threads for a particular, particular machine. So these are the problems basically. Now the question is, what is the solution? Let me know if you have any questions so far, and if you have any, I can definitely try to entertain 1 or 2 questions before I move into the next part. So yeah, all right. Anyway, the solution gets to be is basically the new things, which is Project Loom, which was introduced a long time ago, and it's been worked on since then. And we finally see the light, which is in September. I mean, next month we're gonna get the JDK 21, which will have these new things, which is called virtual threads, and I'm gonna explain what it is now. So before going into the virtual threads, let me show you a small demo. Let me see if I find it over here. So what happens is over here. So this is basically I'm not gonna run it. I'm gonna just explain it a bit. The idea is basically it's the simplest form of server. What it does is it's in a loop. It skips so I'm gonna remove this line for here. So basically, when it gets the request, it handle that request. So basically, whatever client sends, it just uppercase and send it back. So this is definitely single-threaded applications. And then if you want to turn into a multi-threaded applications, what I can do is I can create a thread on an ad hoc basis. Basically, whenever a new connection comes, I'll create a new thread and put that responsibility to that particular thread. So this will makes my server a multi-threaded server, and it will be able to handle a lot of connections simultaneously. The only problem is that we have no way of controlling this, right? I mean, how many threads we're going to create? If I have a DDoS attack, let's say, it will create a bunch of threads, and then once it's run out of memory, the application will die out. So what we can do, we use usually executors to control, basically thread pools to control the scenario, right? We cannot, let's say I want to control this, the number of threads we want to create. We can create 100, we can create thousands or something like that. Anyway, so this problem, but again, if we limit the number of threads, then it's basically our throughput also gets limited. And that's where basically virtual threads comes into play, and virtual threads basically remove the limit. Basically, it means that we can create ideally millions of threads. So let's go ahead and see how can we do that. Okay, there's a class already called playground. Okay. Let me create another class. So what I'm gonna do is basically, so to start a virtual thread, it's simple. It's exactly the same way we used to create the the earlier the way we used to create threads earlier, which is we create an instance of threads, and then so it's basically same construct, but only thing is we have a different method in thread class, which is called start virtual thread, and then this is the virtual thread basically. So if we use this construct, we don't have to do anything else, because it's already started. It says that, and inside basically it's a virtual thread, and we can in fact print that. Sorry. Let's see. Something went wrong. Idea is not taking my comment. Okay, so I have to type all the way. That's frustrating. So thread dot current thread get name. Let's say not get name. So I want to print that part. So I want to see which thread it prints. And so if I run this, I'll see that's a virtual thread basically, and there is multiple ways to create virtual threads. Thread dot virtual, that's a factory method, and then you can start similarly, right? And if you don't want to create virtual thread immediately, start virtual thread immediately, you can do something like that, of virtual unstarted basically. So it will give you a reference unstarted threads, and then you can definitely start the way you want or when you want unstarted start. So same things basically. Now that we have a nice factory method, so they thought it's nice to have a factory method for our classical threads, which is basically the way we used to create threads earlier. So now that we have a two distinction over here, one is virtual thread. Now that we have virtual thread, the other one is the classical one that we used to have, old way of doing thing. We call them virtual off platform, and we are not removing them. We are still gonna keep them, and it's still a huge part of our Java ecosystem. But virtual threads definitely has its place, and we're gonna discuss this. Let me continue to the slide. So that's basically, now the questions gets to be how virtual threads basically essentially works. So that's I'm going to spend the next few minutes, and then I'll probably show you some demo as well. So basically there's two things over here, in implementations wise. I have a picture over here. Let me know if you can, see this image clearly. I'm going to explain it one by one. So now that I explained, we have two kinds of threads in Java ecosystem. One is, one is called the virtual thread, and the other one is the classical one. Classical one has a different name. You can call it native threads. You can call it classic threads. You can call it what else you can call? You can also call it carrier threads. The reason why I'm going to explain in a minute. So classic, native, whatever you can call it. So basically what happens is operating system has a scheduler, right? And operating system gives us the native threads. So, and Java has a Java thread, which is basically a thin wrapper on top of that. That means there is a one mapping with OS thread and Java thread. And let's call it a carrier thread. It's also name of the native threads basically. So and now Java is introducing a new layer, which is basically over here JDK scheduler for and pull. We already had that for a long time since Java 7, which is a new kind of way of doing. It's basically a scheduler. So, and fork join pull has a, seem to be performant in many areas. On top of it, there are various, features of Java has been implemented. For example, stream one of them. If you want to do parallel stream, it's basically use the, JDK fork join pull. Anyway, so now we are going to have a new construct called virtual threads, which is basically a same kind of thread. From the user perspective, from a developer perspective, it has all these elements that classical thread had. The only thing is this virtual thread is not managed by operating system. Operating system doesn't know virtual threads. It doesn't schedule a virtual thread. So virtual thread is basically scheduled by this JDK scheduler, which is fork join pull. Okay. So what happens is when we create a virtual thread, and it's basically taken by this JDK scheduler, and it is scheduled. We can have millions of them, and in the earlier layer, I mean before the JDK scheduler, we'll have a few classical threads. Let's say call them carrier threads, and this carrier thread is basically essentially going to execute this virtual thread. So what happens is, let's say I have a virtual thread and I want to do certain things on that, and I have many of them. So the JDK scheduler is basically going to take them one by one, like FIFO order, and it will keep on executing them by these carrier threads, basically. So that's what happens. Now the questions gets to be how it's better, how I mean, it's doing the same thing pretty much, right? I have a work that I want to execute it by a thread. Carrier thread could do the same thing. Why we need a virtual thread? So that's where things get interesting. So what happens is virtual thread can pause itself. Basically, let's say it's being executed by fork join pull, and a point of time it can it can remove itself and goes away from the scenario and goes somewhere else. It stays in the heap, and it can freeze that carrier thread, and carrier thread can pick on another virtual thread. So now the question gets to be when it's required. So in our modern web application, let me give example of web applications. So what happens is when we get a request, let me see if I have any other photo. Okay, we don't have that, no problem. So let's say I have got a request in IO operation mostly, right? So I send a request to the users, to the servers, and servers do certain things and do certain processing. It also calls other services for services. While doing all of those things, it takes time because there's a network delay. So what happens is, let's say I have a classical threads or native threads, and it doing all of those things. What happens is most of the time this thread is basically idle because it doesn't doing anything. It's just waiting to socket to get the result. Let's say it's calling databases. So database will take some time to respond, right? Meanwhile, this particular thread is not doing anything. It's just staying idle. So if you take average all of those threads, you will see most of the time, let's say 80% of times, threads basically stay idle. So it doesn't do anything. So what happens is we have a limited number of threads, and if the limited number of threads most of the time stay idle, doesn't do anything, that means it's a waste. It's a resource waste, right? So we can utilize what we want to maximize our outcome or resource if we could use them all the time. So let's say I have 100 threads, and if they work all the time, they doesn't wait for anything, that doesn't get wasted. That's the best outcome that we want to get, right? So that's essentially in this scenario happens. So that we have a limited number of carrier threads or classical threads, and they are managed by JDK scheduler over here, and we get a lot of tasks, which is all of them in form of virtual threads. And a virtual thread comes on a carrier thread. It's called mounting. So one virtual thread gets mounted on a carrier thread, basically our a old thread, and it start working. And when it sees an opportunity, or when it gets blocked, basically by network IO or something else, or maybe sleep, it immediately revoke itself from the scheduler. So it goes away. It stays in the heap until it is resumed later. So what happens is a virtual thread call a network operation or a microservice, and it will take let's say 300 milliseconds. So it immediately goes away to the picture. It's wait over there until this response get back. Now this carrier thread is freed, and it can now process another virtual threads. So even though in memory we have millions of virtual threads, it doesn't make any impact. So our number of limited carrier threads is always being working, and since and they are not being idle most of the time. So they're basically, so that's what essentially happens inside. So to summarize, virtual thread is extremely useful when we have a blocking operations. We have we have IO operations. We need to wait. So that's where it excels. That's why we can gain high throughputs. So, and web application is ideal example for that, because in web application there is a lot of IO operation, there is a lot of waiting, there is a lot of just being idle, and virtual thread can stay idle without consuming CPU. On the other hand, carrier threads or classical threads, if they are idle, they're still consuming resources, right? But virtual thread, they're just staying in the memory and they are not, consuming CPU cycle or anything. And we have virtually no limit of virtual threads. We can have millions of them, and some of them are staying idle. We just don't care. We can, if we have another request, we can just get another virtual thread and hand over that request to the virtual thread. And when it gets the opportunity in the JDK scheduler, it will start, and then it will see an opportunity, which is basically, being idle or in the network operation or anything. It will just go away. It stays in the, heap and wait for its turn. So that's essentially high level how virtual thread internally works. Let me know if you have some questions, because we are almost, we don't have much time, but yeah. So if you have questions, now is the time. Meanwhile, I will prepare some demo for you. So now that I said we can have millions of threads. So there is a code over here you can definitely look into. But if I run this code, I'll show you that it in fact can create millions of threads. So if I run this, so what I'm doing over here is I wanted to create 10 millions of threads, and you see over here, it in fact created 10 millions of threads within fraction of times. And it used only 10. I have only 10 cores, and to run all of these things, all this virtual thread it uses only 10 platform threads, or carrier threads, or native threads, or classical threads, whatever you can call it. So virtual thread you can call. So the highlight is virtual thread is basically a Java construct or user mode construct, which is extremely suitable for blocking operations. Whenever you need a blocking operations, you create a virtual thread and give that task to virtual thread, and then forget about it. It will be done automatically, and you can create millions of them. So that's a highlight. But here's the caveat: you shouldn't use virtual thread for processing. Because processing while you are processing something, let's say calculations, and there is no waiting involved. Calculation skips on processing, right? So for calculation, regular threads is the way to go. Virtual thread is only applicable when you have a network operation, you have to sleep, you have to wait. That's where it's excel. And our modern web application is a really great example of that, because there's a lot of waiting involved in our web applications. So that's where it's extremely appropriate, and that's why a lot of frameworks is trying to incorporate virtual thread in their framework. Spring one of them, and hopefully once JDK 21 is released, many of the other frameworks are going to integrate virtual threads in their framework. So you can you will be using virtual thread without even knowing. Maybe back in the background they're doing all these things with the virtual threads. So yeah, that's the idea. Let me know if you have questions.
Bazlur, maybe I can ask a question about the pool sizing. So number of pools, looking the one in your example. So can we set a property from our JVM options for the max pool size for the virtual threads?
Okay, so what I understand okay, so let me finish your question, then I'll reply.
Any parameter should doing this job?
Okay, so here's the thing. So in Java, we have a default fork join pool, right? And for virtual, they have a dedicated one, which is dedicated virtual, dedicated fork join pool for handling virtual thread. And the idea is the number of threads inside the pool is usually associated with the number of core you have on your computer, right? So it's a default one. Still, we don't have an option to customize that. It's a default one, and to be honest, we will never need it. There will be a never situation. Hardly, it's my best guess that you have to customize that pool. So the idea is virtual threads. To run virtual thread, you basically need the amount of the amount of thread. Sorry, let me rephrase that. So basically, you have let's say a lot of virtual threads, but millions of them. And how many carrier thread do you need to execute all of them, right? That's probably is the right question.
No, any property for the maximum pool sizing with virtual threads. Can we set any specific argument for this issue, or
there is probably a way to do that, but that's not on top of my head right now. But I'll definitely get back, and if I find anything, I'll definitely share with you later.
Okay.
But the idea is, what I can say is there will probably not be a reason to customize that. Let me tell you why. So basically, let's say you have lots of virtual threads, and those virtual threads is going to be executed by a fork join pool. And how many threads you need in that fork join pool? That's probably the number of core you have. The reason is, let's say you have 10 core machine, and you have 10 virtual threads, 10 physical classical threads inside that pool. So basically, if you distribute evenly, all of the core will have one thread, right, to execute all these virtual threads. And if you add more classical thread, basically they are going to compete each other. Some of them will be they will be rescheduled, right, in a fashion called round robin. We don't need that because one thread is always continuously being executed all the time, 100% of the time, and they are always executing virtual thread one by one, right? So probably we don't need it. So that's my understanding, but I don't know the scenario where it might require. So probably there is a way to customize that. That's not on top of my head. I'll definitely look into it. Okay. So there is a way. Thank you, Daniel. There is definitely there probably a way to customize that. I forgot about that. Probably, okay. Yeah. So thanks, Daniel, for sharing that. Which is basically there is a system property. Yeah, I assume that there should be, and I don't know the applicability yet, but yeah. Highly in most cases it is probably default is good enough for in most cases. So anyway, let me conclude my presentations. I wanted to show you the demo continuation, but let me see if I can show you what it is. The continuation is basically the construct that internally used to revoke so basically what happens is when you start virtual thread, and virtual thread gets mounted on a classical thread, right? And then when it releases a blocking operation, it unmount itself so that it can resume later. So the whole thing is done by a concept called continuation, and it happens internally. You don't have to do anything, but it's good to know how it works, right? So what happens is, let's read that code and see, try to understand what happens over here. So I created a continuation scopes, and over here, basically think about that this is a thread. Like, think it's not, but think about it. So what happens is over here, from this curly brace to this curly brace, I'm going to execute this line, 3 line. So I'm going to start with C1, and then I'm calling continuation.yield, and then I'm calling another method, which is print another line. And then I start over here, continuation run. Then there are a few other statements. So the questions gets to be, if I run this code, what will happen? What would be the execution order? Anyone? So what happens is, ideally, if you call a method, let's say there is a method, public void do something. Let's say there is 1 statement, 2 statement, 3 statement, right? So, and you are executing over here, right? And you came over here, and then somehow this method exit, and then if you call this method again, it will immediately start from top. That's how it is, right? But that's something different with continuation. What happens is, if you start executing, you execute line 13 over here, and then you see an opportunity to yield yourself, basically return from these executions, and it goes away. And then when you come back, you will start immediately after that. So you won't start from the top again. So that's what happens with the virtual thread. So let's say in virtual thread, you start a network IO operation over here, basically calling a microservice. And since it's a blocking operation, you're going to yield yourself. It goes away. It stays in the heap. And then let's say all this work is done. You have got your chance again. And you are being executed. You'll start immediately from the where you yielded, and you will start finish that. So that's an interesting concept. And to accommodate this virtual thread, a lot of IO operations, IO related work, library in JDK has been rewritten to basically accommodate the virtual threads. It's an overhaul, huge changes. So now most of the IO, I would say pretty much all of them, I guess, support virtual threads. So inside there's things called continuation and all those things. So basically, it can check whether it's running on top of the classical threads or virtual thread. If it is a virtual thread, and if it sees that I'm going to block myself for a while, so let me yield myself so that I'll come back later. So those are in JDK 21 you will be able to see huge set of libraries has been changes. For example, all this I have a list over here. I can share with you these slides. You can check. Okay, so I have added this line over here, and there are a lot of updated API. Basically, you can do all of those things. Anyway, so highlight is there are many changes, and there's certain resources that you can definitely look into. Anyway, so what are the benefits basically having the virtual threads finally? One is definitely we're gonna get higher throughputs now than earlier. I mean, we can easily do so what alternative we had earlier? We could go route to what do you call RX, I mean reactive stack, right? The problem with reactive stack is it has higher there is a learning curve, and then it gives you a higher cognitive loads as well. And secondly, when you start writing a reactive code, you have to stick with that. You cannot back and forth, like half of the code is reactive and half of the code is traditional way. You cannot do that. You have to write entire code base in a reactive fashion, and the another problem is with reactive programming is, debugging is extremely hard. The way you see in the code, it never gets executed the way in the in JVM, right? It's completely different scenario. So it gets hard, and the one of the interesting thing is we proud of in Java is stack trace, and if you see stack trace of reactive programming, it's completely horrible. It's difficult to find problem from there, and all of those things. But using the virtual threads now, you don't have to worry about all those things. You literally don't have any new learning required to use virtual thread, but something you may probably need to unlearn. For example, you no longer going to use thread pools anymore. Use of thread pools is basically it's removed you from I'm sure those who configure thread pools, it's always a headache. How many threads we're going to use? It requires fine tuning, and it requires a lot of work. But since we no longer have to use thread pool, that's a huge relief. And the idea is you can use virtual thread as task. Whenever you need a blocking task, you can just create a virtual thread, and that's it. And you don't have to worry about it. So there's a lot of benefits of using virtual thread, but keep in mind, this is only applicable when you have a blocking operation. For non-blocking operation, I mean, for processing, you're definitely going to use the traditional one. So that's the idea. I'll end with a few quotes over here. So it's Ron Preston, who is the guy behind this virtual thread. What he says is virtual threads are cheap enough to have single thread per task and eliminate many of the common issue with writing concurrent code in Java. And there is another quote, which is, there aren't many new API you have to learn, but you do need to unlearn many habits, such as using thread pools to deal with resource contention. So yeah, so that's two interesting code. And I'm sure I'm on top of the hour. So finally, what I'm going to show you is if you want to keep on, I'm writing a series on virtual threads. So if you want to follow, or if you want to keep updated, you can definitely follow, subscribe to my newsletters, where I write a monthly newsletter with a lot of interesting stuff, mostly related the updates of the what's happening in Java community, and lots of tutorials and other things. So you can definitely keep an eye. And there is another initiative I have recently started. So let me share that as well. So if you have any questions that you are sort of trying to get answer, but probably you haven't. So what I'm created is, let me put it over here. So there is an initiative that I have created, which is Ask Me Java. Basically, there is a discussion board over here. What you can do is you can ask questions. So I probably won't know all the answers, right? So what I can do is I'll try to come up with the answers. If I know the answer, I'll definitely try immediately or help immediately. If not, I'll probably try to reach out other person who I know probably have the answers, and then I'll write a article about it, or share on my newsletter, or any other ways I'll try to, or in a LinkedIn post. So because I do get a lot of questions from different channels, so I thought, why not concentrate one place, keep everyone in one area where they can ask questions later offline. So yeah, that's another places where you can go. So let me share these links to the chat. So if you want to, ask me any questions later, that's the place to go. And apart from that, you can definitely, it's a LinkedIn newsletter. You can definitely keep an eye. So thank you all. That's all I had. Thank you for your time. and hopefully, I wanted to cover a lot, but due to the time constraint, I was not able to cover all these things. But yeah, I'll share the slide deck with you. Let me share now, in fact, speaker desk. So that there is the other resource that I documented in the slide deck that will probably, if you want to go through. So let me share that in chat box. So that's the slide decks. Yeah. Yeah, that's all I had. Let me stop sharing.
Thank you, Bazlur.
Thank you. Thank you, Bazlur.
All right, guys. Thank you again for hosting me. Hopefully, I'll future. I'm looking forward to meet you all in person, and I definitely want to visit your beautiful country. Especially, I've been waiting a lot. When opportunity comes, I'll definitely pay a visit to your beautiful country. It's a lot of history and a lot of interesting things that I know, but never been able to experience in person. So looking forward to it.
Thank you. Thank you. I hope so. Maybe in Java Day.
Maybe, yeah.
Yeah, maybe. Okay. Okay, my friend, are there any questions to Bazlur? Yes. Last call. Okay, I think no. Okay, hope to see you again, Bazlur. Thank you for your valuable informations. Thank you. Hope to see you
Take
soon.
care. Bye-bye.
Bye-bye.
Assalamualaikum.